Let us close the doors. Good afternoon once again. We invite you, please take your seats. We invite you to this session with a thrilling name, Safe Approach to Industrial Internet Implementation. Today and on most of the other today's sessions, we have a balanced representation, both customers, clients, the industry software manufacturers, and I am going to moderate this conversation. I work at a consulting firm, KPMG. I'm in charge of emerging technologies in risk consulting. My name is Nikolai Lehkodimov. We have a little slant towards oil and gas industry in terms of speakers today, because I've also worked there for a while. So what I would like to begin with, for those of us, this agenda of digitization or automation, let us not go into details. If you've been working on that for a long time, it's pretty clear that this initial hype is over. Everyone has learned to talk about blockchain, machine learning, and artificial intelligence in a more or less clear way, about unmanned vehicles and so on. We now have some experience of new technologies implementation and what challenges it involves, and not just technological challenges, but also cultural challenges and in terms of in-house corporate structure at companies that are implementing these changes. I suppose that if 3 or 4 years ago, when we were talking about the emerging technologies in risk, there was this visionary approach. What will digitization do with the labor market? What will the artificial intelligence do to managers' responsibility for decision making? But now we can probably talk about some down to the ground, practical solutions and implementations. I would like to introduce Denis Kasimov, General Director, Clover Group. You will probably introduce yourself better than I can. We've worked on some projects on predictive analysis and machine learning together. So, Denis, you have an obvious industrial profile of your solution. You have a solution for the oil industry, solutions of different maturity level. So what risks can you identify? Which of them have you faced? The more pragmatic your discussion will be, the better. So you're welcome. Thank you, Nikolai. A good question, actually, and it's quite thrilling. As a whole, when we started doing it 3 or 4 years ago, we were after one ultimate goal, that data is an asset. Data is the new money, and the person who begins to process them cleverer and faster than others for their needs, it's not about winning, but they will make a lot of money, and that was this ultimate motive. After that, we focused on the industry, on a specific narrow segment of predictive analytics, this intelligence that is coming and telling you when a piece of machinery is going to fail. And these things are now working. But, as usual, there are some limitations. We faced challenges and pitfalls frequently, and then continue to move forward. So as for the question of risks, what the risks are, the first and major risk is actually how to make an innovative product, and all such products are certainly innovative because we're talking about emerging technologies and new products and so on. How can you make it safe? and this answer will be multifaceted. There is no way, actually, or almost no. You just have to approach it in a very careful way. And before doing anything, you need to assess the financials, whether you are going to get anything from that. Also, you need to realize that from the project implementation point of view, any project can turn out to be unsuccessful. We have such case studies too. When we tried doing it in a certain industry, it was not a success, so we stopped working with this industry. We are only working with the successful ones. What about unsuccessful? No financial benefit? Yes, technical predictions is working. I don't think there are any people left who are still skeptical about it. It works, the technology is working, and you can get a result. But it often happens, or it used to happen. I think we've looked at all industries by now and decided not to work with some of them because the financials don't work out, because the business model that exists at our customers' companies is not yet capable of using this technology and this specific solution. We are fortunate with our current customers because mostly they're getting the money from the working equipment. If they are profiteering on equipment repair, the top management says, yeah, cool, let's do that. But the middle management, that, to put it mildly, is actually interested in doing repairs, is saying, no, guys, I won't let you near it. You will not do it even if you can show the result. And this is always the struggle. It's always this pitfall, because business models are not yet transformed according to this new digital paradigm. And the second risk, or the second model, is data security, which is the topic of our today's session, because data needs to be securely collected from the manufacturing, securely stored, analyzed, and securely yield a result. How do you do it if you don't put a server next to a piece of machinery is quite a complicated issue from the technical viewpoint. The infrastructure is often not ready. Security systems that companies are in the baby shoes, and the secure data infrastructure is often non-existent at customers' companies, and it's also a problem and a risk for us. It's a risk because we can do a great job, but to launch it, we need to upgrade the network and a host of other things. These are the two major risks we are now facing and that we are going to face in the future, and a solution already exists for them. So at the corporate level, in the cases where you feel certain resistance, is this resistance coming from the functions like chief mechanical engineer or IT or security? Who is resisting the most, and how do they explain it? If we prioritize, then it's certainly the easiest with IT guys, because we are also IT guys, and we can find a common ground. After that, after them, we also have technical expertise, so we are simply sending a technical guide to the technical customer, and they speak the same language. You can always find a common ground, because the person at production has a specific problem that can be solved. It's not always about what we are doing, but usually it's possible to solve it, at least partially. And after that, information security. That's the guys who show the most resistance. Security guys, that's classic. Thank you. I would now like to give the floor to Raul, who represents Gazprom Neft, and he is in charge of downstream innovations logistics, processing and sales of oil. Gazprom Neft, and it's no secret, is quite advanced in business digitization, at least in the downstream segment. We've worked a lot with Gazprom Neft, and many of the problems of resistance or inertia that Dennis has mentioned are relevant for you too, like the issue of informational security. Nevertheless, you are moving forward, of course, incrementally. And I think you are setting quite ambitious or maybe ultra-ambitious goals. And there was a lot of discussion lately that you are shifting to a new business model. You are planning to create a digital platform that would include all data from all instrumentation and automatic process control system, and this data would not go to IT departments to implement certain applications, but you would be doing it yourselves with this digital platform. Please tell us what risks you are already facing or are planning to face.
Good day, dear colleagues. As it has been mentioned, my name is Raul Tinchurin. I'm busy in the consulting of downstream sector in Gazprom Neft. We proudly called this system EVOIL, Evolution and Oil, in Oil. This is actually one of the first experiences of implementation of digitalization in the oil industry in Russia. Open source products are not completely import substituting, but they reflect the needs of today, and they fully provide for our economic strategy of development. It was quite well and true. We want to collect all the data on the processes within our company on the level of technology, production and business, and make a certain lake of data, big data, and implement the concept of some Android store, an application shop, which can be adjusted automatically and can be scaled by functions and productivity, and also scaling the typical assets. And the concept when our smartphone applications, we can these applications do not need a certain adjustment. This is our idea. We certainly do only first step, make only first steps, and there are not yet many real solutions in this field, but it's the right idea and very ambitious idea, and the transfer to this one a cooperation process, open process. In my understanding, digitalization is when IT stops being the company resource and goes behind its limits. It's about the integration of system of partners and raw material suppliers. This approach allows us to connect in one system all the aspects, including the supplies of raw materials. It certainly causes a lot of risks, not only opportunities. And it's not my author idea that the cooperation of these industrial trade ecosystems allow as a priority take that or this decision on the processes, including the adjacent industries, but this integration allows us to eliminate the gaps between the continuous processes of oil processing, of construction of roads out of bitumen, of crude oil supplies to our partners, etc. And the topic is industrial IoT has inherited a number of problems characteristic for any industrial solutions. In the beginning, this topic of informational cooperation with the automated systems of control was physically separated from the plant. So all the ideas which were in the basis of this system, they were were not connected with the rest of it. But in order to reach the progress, we have to run twice as fast. So we did not want to do the complete re-engineering of all the systems and carrying a number of risks and damages to go to the extended enterprises when we connect the integration enterprises with the external companies in order to create the full value chain. This is another damage. And the last thesis which I would like to mention, speaking about the risks or damages, this is the transfer to the open innovations when things are being developed together in an open, with an open code, which allows everyone to get involved and well integrate the efforts, including the monetary efforts. But open codes allow people with evil thoughts or ideas to get integrated into this system and develop some cyber attacking codes. They can be planned on purpose, or it can be on the interconnection of artificial intellect. When Knight Frank company, for instance, trade selling robots has generated a lot of damage because looking through the list of applications for the it provoked the loss of the share course. This interconnection of artificial intellects, when I'm speaking about these extended enterprises, when we connect this algorithm of different companies, they may cause some risks as well, which could not be predicted beforehand. And secondly, the risks may be connected with some terrorism. Well, maybe not criticizing you, but about challenges. Maybe they are very ambitious plans, but not always applicable to our reality in the gas and oil industry. Not looking into your P&L. Maybe your two largest counterparts are RZD and Transneft. As any other, I think Russia is a company which is on a certain level of, they are companies which are on a certain level of digitalization. Maybe they do not fully comply with Wink, but it's a documentary style. It's a lot of paperwork. Involves a lot of paperwork. Is it integrated? Is it possible to fully transfer this to the digital form, or provide them on the level of measuring means and the primary data you have to work with to build the digital platforms? They are not there. This is more a corporate issue than the technological issue. It's a very frequently asked question when the infrastructure, basic infrastructure, is not there. There are 2 points. The first about the general vector. It's not invented by me, but there is a well-known saying that the electrical light appeared as a result of a continuous improvement of candles. The pragmatic answer is more sort of applied answer. In order to build the correct digital process with all the algorithm and data, It's not necessary to 100% cover all the initial processes. You first need to understand how the target algorithm should work, and then collecting the minimal amount of necessary data, you have to understand what else you need to equip, and not doing one by one, but you should use the principle, well, this data you need 100% because they are very crucial, and these data, are good, but not really necessary. And it's not expedient to equip the these processes with basic automation equipment. Okay, it's interesting. I'm sitting between two oil oil people. Alexei represents an internal integrator of Rosneft, which has also made a step from candlelight to the electrical lamp. This platform has been discussed already here, Predic's solution. Alexei is directly responsible for this project, which is a successful project, and please share with us what risks you faced. Not giving a direct answer to your question as you like, I would like to get back to the topic of safe approach towards implementation of industrial internet. Maybe go back a little bit to the beginning of our dialogue, when it sounded that perhaps we all learned how to tell about blockchain, big data, machine learning, neural networks. It seems to me not. We have not yet learned doing it. Not every one of us. And very often in our dialogues, two people using the same terminology, they mean absolutely different things. And here also, if we are speaking about safe approach towards implementation of industrial internet, we are now approaching or escaping to the zone of digital platforms, which, from my point of view, are more advanced and modern platforms for mass systems, but not they do not solve, or they are not the platforms for the industrial internet. In my opinion, again, I want to emphasize, in my opinion, is when the industrial internet is when on the level of a specific industrial process, like an oven operation or some heaters or whatever, you have an interaction of various parameters of this promise, temperatures, usage, etc., which provides you a certain connection, and it improves the control of technological process and allows you to take some technological decisions. And from this point of view, this is one part. On the other side, there are our digital platforms. Together with Gazprom Neft, we have not only oil fields in common, we also have a very good human potential, which is interconnected in a way, and we are more or less, maybe we are less flexible, but we move in the same direction. As Nikolai mentioned, we are approximately in the same trend. The decision was made in order to accelerate implementation of new technologies. We need one platform, the digital platform, for provision of 4 key things, for for appearance of new level systems, very fast collection of data from technological objects, the speed of implementation of the systems, similar to those mentioned by my colleague with Android, iOS, where we have open protocols, and speed of implementation if you have a cloud structure and an opportunity to collect the data from all technological objects. You can implement your idea very fast. Vertically integrated company, they have difficulties in implementation of any process. For instance, for me, an elementary problem is to collect the data on chemical analysis, for instance, because I have more than 150 daughter companies, 500 laboratories, and organizationally, this process becomes very, very difficult. And from the point of view of these platforms, the progress itself, when new systems appear, becomes faster. If you come back to the industrial internet, when we are speaking about safety, safe approach, how the industrial internet is different from STP systems. Maybe the mistake of an algorithm, the wrong influence towards the industrial process, violation of some modes of equipment use, violation of some technological modes. Here, possibly together with the security service of our company, we can understand the model of risks or threats. It does not change. Where I can see the threat to our business from my point of view is that we nowadays are facing new problems of working with bigger volumes of data. My colleague also mentioned the digital platform, where we plan to collect the data from all the technological objects. A lot of streams of data. Also, do we make an average? Do we receive an average data or just raw data? How does it influence the result of this algorithm operation? We also enter some terra incognita when trying to create the systems with the use of some neuron networks or machine learning. Where is the guarantee that we have learned this algorithm in a correct way, that it won't present us some solution which, when applied, can cause some dangerous reaction? And there is another danger which the generation, maybe not our generation, but the generation of the current students will face, maybe the blind faith into the correctness of the calculation of the system. When we did something by hand, we could check things or touch upon certain things like pipes, etc., checking whether it's hot or not. The generation today has a more blind faith into the correctness of a certain system. If the system tells you that is it, I have to do this way. And it seems to me that it presents one of the dangers. Thank you, Alexei. Possibly, in spite of the profile of our session, is more or less IT and technological, I would like to turn our discussion towards the business case discussion. well, the technologies work more or less. We understand this, but and this is the question also to you, Ravil, how well the companies can implement this business prompts, business solutions which are given by the systems. All this stuff, all this story. I believe that even in Rosneft today, on the level of a specific company, on the level of specific production cycle, it's quite difficult to forecast that a certain unit will fail in the process of work in a certain time. It also relates to the warehouses, to availability of various spare parts, etc., etc. Well, is industry today ready to implement this understanding which is given by the systems?
I will try to answer this question with case studies. As for reliability management, specifically reliability management modules based on the estate, like Predix, or maybe you've heard about Arodun, the company bought by General Electric. This solution has been implemented at the Omsk plant for dynamic equipment, or simply speaking, pumps that cost millions of dollars, and they are in a critical place inside the plant, and if they are not working, the plant shuts down. We have the downtime cost for the plant calculated in a simplified way, but it's obvious for everyone. There are hundreds of times the cost of implementing this solution is hundreds times less than the costs they would incur if the equipment was working until failure. After that, I would like to talk about advanced process control, reducing this quality potential without increasing the defect rate at the output costs so much money in the pilot chain that the payback period is 2.5 months. This solution pays back with a cognitive module that creates a statistical model and understands how to use different additives to the oil to influence quality parameters, and we call it cognitive process engineer. It reduces the downtime, and the quality is still objectively high because excess of additives can actually deteriorate the quality of the oil, but it reduces the cost. And the payback period for that is 11 months. Also, we built a unit for initial oil treatment, to put it in simple words, and this model operates 3,500 signals received from sensors in the real-time mode, and it can enable the future forecast analysis to predict how this unit is going to operate in certain conditions and what kind of results you're going to get. Of course, you can use this as a simulator for training without actual risk to production, or you can build it into the control circuit. This is still a pilot project, and the system is supervised by a human during this training stage, but that's an actual case of process control. Thank you. Thank you. I think we can hear. Yes, Alexei, of course. Excuse me. It's just that what the previous speaker was saying demonstrates that the oil industry is has been digitizing for a long time, because these systems emerged and have been developing for a dozen years. And for the oil industry, this topic is hype at the moment in various industries or in various parts of the oil industry working with digital technologies and algorithms, starting from geological exploration and finishing with oil processing. They've been used for long. And as for computing capacity, the oil industry in combination is probably second only to the global defense industry. Rosneft is going along the same path. It's a trend in the oil industry. Meridium, reliability management of both rotating and static equipment, and it's implemented in the production and processing, and this advanced process management system is also being implemented at initial or secondary plants, or sometimes even at higher processing stages. The problem is as follows. If we get back to business case studies, on the one hand, we do have benefits. On the other hand, it has been said correctly that if this is critical equipment, an expensive compressor or, let's say, a pump, if it's critical equipment, then it has a redundant one. The system, the reliability is built into the system of production itself. I know that process engineers usually can judge by indirect indicators when a certain equipment is going to fail. Of course, there are emergencies, but in case of an emergency, we do have a redundant compressor or even a redundant line. But for these systems to be really financially effective, Nikolai is right. A system must be comprehensive. So the deliveries must be just in time. If I know that tomorrow a pump is going to fail on a highly productive well, especially if it's in a remote location, I'm ready for that. I have already delivered some equipment there. It has been purchased and so on, but our industry does not operate this way yet. And I have a dialogue in the processing part. It's a little different, but in the oil production business, they use a lot of electric submersible pumps. And our colleagues from GE or other companies are coming and saying, we will be able to give you a precise estimate of when a certain equipment is going to fail, plus or minus several days. Firstly, the mean time between failures of submersible equipment is 600 days. So mechanical engineers already know when they are approaching the end of this mean time between failure. So they are ready to replace this equipment. The only benefit it can give us, and this is true, is that we can plan operations in the field or at the factory better. It's no secret again that we're not working in IKEA with with the space of 1 square kilometer. At the field, the space is 300 square kilometers, and bringing people there requires some effort, and you need to provide for their safety too. Nevertheless, the driver that prevents it, why is it not happening? I suppose the problem is wealth. I've worked in the oil and the mining industry, and usually our problems are caused by our wealth. If the field, let me just say one thing. There was a large conference recently, and a representative of our oil industry said, "Colleagues, you are talking about high tech, but the cost of lifting the oil out of the ground is $3 per barrel, while for Shell it's $15 and $18 for Stud oil. We can, unfortunately, afford to lose some production. We can live with inefficiency. So if a pump is down and we replace it in a day or two, yes, we lost some production. But with our costs, no one will even feel this loss. And this driver, or rather a threat, prevents new implementations, the implementation of new technologies. And to round up the oil topic, it's a popular misconception of the upstream, because you are calculating the cost without the logistics and without the tax burden. But oil industry in Russia is not as profitable as people in the upstream processes at the field would like to think. Finishing with the oil and gas industry, which is probably not interesting for everyone present, I'd like to expand on the topic that's been mentioned by Dennis already and by other colleagues too. It's protecting automatic process control systems and the systems of instrumentation on equipment that provide initial data for mass level. Unlike some process details that we've been discussing today, journals and newspapers are also often writing about the risks for automated process control system. It's been 5 years or more, and there was this virus called Stuxnet, and some people are nodding. The IT world believes that it was developed by Israeli special forces. I'm not sure if it is, but the virus damaged or stopped processes at Iran facilities for uranium enrichment, and this really made all people nervous who are involved in automatic process control, including Russia. And I'm sure that the same was felt throughout the industry. So, are these risks merely PR, or are they real? Let's discuss that. Maxim Lipatov, technical director of our tech. Where is this border? Should it be an issue of the Internet Security Director, Chief Security Officer? Is it just a hype? So what is your opinion of that? Thank you, Nikolai. Good afternoon, dear colleagues and dear guests. I would like to strike a more practical note. In this dialogue, we've been implementing predictive analytics systems for a number of years. It's analyzing the technical condition of complex industrial equipment. And Dennis has said that difficulties arise at all stages and at various levels. I can say too that difficulties arise at all levels, from the grassroots personnel who doesn't want to be monitored by the big brother, process engineers who believe everyone who is supervising or monitoring them for predictive analytics or other systems, they are not good enough, and they don't have the knowledge that they have from their expertise. Then at the informational security, at the cybersecurity level, it's very bad, because a security system of a large corporation doesn't want to share any data, from process data describing the process and that has mostly academic value. And I suppose that this data should create this league where startups could be thriving, and any parameters that we can receive is confidential information of the company, and yet There have been cases when we were discussing the implementation of our system, and at one large corporation, a person said, yes, we have to get approval for simple things so that you could consider whether it's possible to implement this system. Yet we transfer so much information through Viber or WhatsApp that you could get a lot of data on this company. So there is a conflict of interest. You could optimize corporate processes, you could optimize equipment life cycle, yet some things are limited by this corporate subconsciousness, including that of cybersecurity. As for protecting the infrastructure, for example, we work in power engineering. We came to the digital technologies not from the top, not from IT side. We came from the bottom. We were originally doing maintenance on gas turbines, and as we performed maintenance, we realized that we needed something for quick data processing and receiving information from a facility. So protecting automatic process control systems. There are various companies and numerous ones. We've already implemented 3 projects. At one company, we have implemented this system at 7 facilities in 5 regions, and at 2 more companies, we are just starting to implement this project. This is open information, Mosenergo, Patenergo, and Baltic Plus. So in power engineering, we are talking about the life provision cycle. It's not just an uranium enrichment facility that was stopped. It could happen that people would freeze in the winter, or a region will be left without electricity. It's a very significant issue, and every company approaches its cybersecurity in a certain way. There are government standards and regulations in this area, and it is all possible to overcome. But we are facing another issues then. We are protecting automatic process control system, and we believe that we are not influencing the operating equipment, but when we are implementing the Internet of Things and moving towards Industry 4.0, we want our facilities to interact with each other through artificial intelligence or analytics systems. We want the equipment, machines to talk to each other, so to say, without personnel's help. But then we are facing another threat, whether the artificial intelligence or the predictive analysis system or predictive repair system, whether they can assess the situation correctly and tell us what to do with the equipment. For example, first, unmanned driving or thrust control systems could reduce the engine power and reduce the speed of a flying airplane in case of faulty sensors, and it sometimes caused catastrophes. The same would happen here if we would send commands by artificial intelligence to the operating equipment. In our case, we are giving recommendations and forecasts on the equipment condition to the operating personnel. We are not influencing the facilities directly, and in the nearest future, this problem will probably not solved until we are confident in the artificial intelligence and the predictive analytics, and whether in the proper reaction and response to the situation. So these risks of influencing the automatic process control system with artificial intelligence or not, do you think that they are accidental? So, for example, there are errors with the company's control circuit when the programmers or programming teams are developing a bad code, or maybe this is specifically the movement against the industrial internet. You know, before the implementation of the industrial internet, all automatic process control systems used to be local, and all risks that could occur at the equipment could be described and were limited by the infrastructure of the company itself. Poor qualification of personnel or errors of the automatic automatic control system due to its development properties. But when we are connecting a facility to the global net, we are assuming the risks that anyone can hack into the system, and these risks need to be mitigated at the hardware and the software levels. So, of course, it's a very important issue, and here we are introducing a lot of uncertainty into the system when we connect it to the external network. Of course, we are forecasting these risks and are trying to eliminate them as much as possible, but there are always these chances. I suppose it would be interesting to discuss how these risks how we can protect ourselves from these risks, what are the means, not just technological means, but also business means, and whether we should change the...
There should be some, on the level of businesses, on the level of interconnection with the contractors, and I would like to invite the representative of Kaspersky Laboratory, Andrei Suvorov, to tell us there are some risks, threats in general, not only related to threats and risks. Maybe, well, some general, maybe the risks of hacker attacks. Perhaps there is a wider scope of risks. Well, I will try to be brief, but I will try to tell you as a detective story. Sometimes people are very shy to ask how the story of cybersecurity differs from what we can hear about hackers, attacks, etc., etc. Good day, my name is Andrei Suvorov. I am the leader of Industrial Internet in the mode of cybersecurity section in Kaspersky Lab. Two parts. First of all, what is being used in industrial companies and how the existing methods of protection help or not. Is it an illusion or not? I will tell our project about the study of the protection of plant. I will give you a real example of the oil processing plant without giving its name, but there are so many plants like it. What applications, number one, what applications are mostly used by the top managers on their smartphone, in their cars? In a couple of days, we have found
there is this vulnerability that even the developer doesn't know about, and you can use this system of paperwork, and you can use it as a gate to get inside the corporation.
The second step, as a rule, is the study inside. When inside the corporative system, there is an attempt to find a privileged user who can already knock at this SCAD application or the application working in the contour of automated system of management of technological processes. And their level of protection is always lower. For instance, the controllers connected to many mentioned physical aggregates receive any command which comes to them. Many of them, they can fulfill any command. If there is a stop command, they will fulfill it. And here I'm going to refer to some other examples. It's in the cybersecurity world. It's absolutely unimportant whether it's protected, what kind of strong protection system system it has or not. Well, the topology of doubling this physical equipment is done in one script. Well, the price of an attack is approximately the same, and only one thing can save it, that part of this equipment is not online, it's on prevention servicing. So first, when you get an access to the automated management system of technological processes, you have to see what kind of vendor do they have. But the level of danger here is very, very big. This is published in internet, and they can be eliminated within 6 months, depending on the level of criticality. Well, you cannot identify these vulnerabilities immediately. Having found a gap in this automated system of management, you have to spend several months, and nobody within the company can see what is happening there. These bad guys get an access to the logics of the technological process, and then it happens that, unfortunately, not always accounted by the cyber security specialists. When pushing the key can influence the hydraulics or automated systems or any other system in the company. When we fixed in our reports at this plant, one of the most expensive installations in this oil processing plant was catalytic reformer. And we have proved that by method of these 4 steps and access to the logic of work of the technical process of this installation, you can destroy this installation in only 2 days. And at that, at SCAD systems and on the top-level systems, getting the information from the same level, from the same SCAD, everything is going to be green, and the normal parameters will be contained in the reports for a long time. As a rule, these factors are evaluated, underestimated in many companies, and this kind of study should be done quite regularly. So vulnerability of zero-day on the level of applications, an attempt to knock and find the access of some strange users to the system, and the access to the logics. This is about the 2D. As to tomorrow, the industrial internet mostly means that we begin to get a lot of information and use it for decision making. In the process of cybersecurity, it means 2 different streams, differently oriented streams. One stream from majority, from many big number of all kind of devices. They have been very well trusted, afforded. If we want to get reliable information about the quality of repair, this information cannot be compromised, and here the whole chain must be optimized. And the second stream is on the contrary, which flows on the contrary from the big number of various devices, is the information on compromitation. We have a security cloud. We can catch all kind of dozens, thousands events on the attempts to compromise the data and information. On the other side, there is no system of fast integration and localization of their systems. In the same way, the information has to be distributed to another side, from the suppliers of this information towards the customer, the information about the vulnerabilities on the level of the industrial system elements. Thus, I try to briefly tell you how important the system of evaluation of protection, real protection of existing systems is before the industrial internet, and what two aspects in the context of cybersecurity have to be taken into account if we are speaking about mass implementation of certain technologies which will allow using the new sources of information. In the Kaspersky laboratory, we have these technologies, we offer these solutions, and I would not like to tell about them today in this session, but certain things will help you to optimize. First, you have to teach the operators who have a very low level of information about cybersecurity. Second thing, you have to check your cyber protection. And the third thing, based on whether this information is serious, you have to take a decision on the solutions to be applied. Okay, it's interesting to me, at least maybe our audience is also interested in hearing the risks which you enumerated, the attacks on controllers on any daily operation. These are sophisticated attacks on the level of engineering. As soon as we are having this oil kind of profile today, in the oil industry up till now, there are some technological processes which, due to some past vendors who stopped supporting them, or they have left their businesses. There are some technological knots of managing the controllers where the control is made by computers of Windows 95 of Windows 3.11. It's been working maybe for the last 20 years, but then there is no reason to change it, and it's so deeply dug in this system of IT department, and to attack such a computer is not a big engineering job. You do not even need to be a hacker, just get a list of vulnerabilities from internet. There are these cases in the oil industry and generally in Russian industry. As a profile, a security company, what do the level of protection or the level of some old systems still exist in the air? There are many. It's not only a Russian story. It is, as a rule, the investments in the system management, automated system management. But the price is rather high, and the story with Stuxnet was why it was so obvious, because the attack was opened or revealed only in 2 years after it was efficient. Was it an Israeli attack? No. Stuxnet not. Yesterday we had an interesting lecture. For the second year, we are only speaking about only cyber security. It was attribution of attacks. Often people want to know who is standing behind these attacks, and we have this information. As to Stuxnet, there is no single version, but there is one version that this attack was effective for 2 years, and the term itself, if you heard, there is another term, APT, Advanced Persistent Threat. In the world of ATPs. The complex attack is the attack which has been made to you and they left, and you don't know about it. There is no confidence, and it doesn't make sense to analyze the information. There are many systems nowadays, even here, which are not supported by vendors, not only by Microsoft, but when a vendor doesn't support it anymore, they continue using it, but there should be some balance found on the level of the company itself. You mentioned APT, but you are monitoring the risk, the picture of the global industry. What do you think from the point of view of the attacks, or maybe successful attacks? I don't know about your analytics on the industrial object. What is the share of APT, or what is the share of opportunistic attacks? We have statistics. Frankly speaking, it's not really obvious. 0.1 is the APTs, including the industrial attacks. But APTs, the level of APTs, or the damage from APTs can be compared to the price of companies. Perhaps you heard of some cases when people are heading to billions, and non-purpose attack is the avoidance of personal hygiene. There were some target attacks when the company got into the situation where they lost $300 million at the profit of $360 million. They had to reinstall 3,000 computers and servers, a lot of servers, and they did not work well for 10 days. It's a global company. They had to reload containers, but it's the price of one attack. So the stakes are really high, and those who protect themselves and those who want to get these assets. And colleagues, now I would like to perhaps give a chance, the opportunity for you to ask your questions. Here you are.
У нас есть микрофон?
Я могу громко говорить, если так будет лучше.
Не, может, просто переводят кому-то.
По поводу Stuxnet. Прямых доказательств нету. Нету таких вещей, которые
There are no things that could be proved in court, but there are lots of indirect confirmations and proofs, like something Obama once said that proves that it was a joint operation by Israeli and U.S. Special Forces. I also wanted to comment on Alexei's speech, who said in his speech that for us, I mean for you, the model of threats has not changed. I tend to disagree. The systems are getting interconnected, sometimes not even at our will, because the research we are doing open up an interesting possibility for some companies. I will not name you the company, but we found a bank inside a metalworking company. It used to be their branch a long time ago, a financial department. Then they started providing external services. Then they separated and became a separate bank, but the computers remained in the network, in the same network as SCADA equipment. These facts are concealed. So since a huge new array of data is emerging, especially industrial Internet of Things, and these flows of data lend an opportunity of influencing in a certain way, intentionally or not, and the model of threats is changing, and you must take these changes into consideration. Thank you. May I give a short answer? Currently, if you show me a company from the oil industry that uses lots of sensors, and then suddenly there are Internet of Things systems emerging, I will be happy to visit this company. Currently, I'm not sure. Maybe they exist somewhere. Maybe there are platforms like that. But currently, if we are installing certain systems, we install them within automatic process control system circuits, and their according to the design rules and implementation rules, which are verified, their lines of communication are physically separate from general corporate networks. So currently, at the moment, I think the biggest threat is coming from either fraud or smart attacks, or simply an engineer who brought an update on a flash drive. In a while, when we maybe start installing real instruments that talk to each other and send the information to the vendor of their condition, maybe, but we don't have such systems so far. You're welcome. Could you introduce yourself? My name is Mikhail Antonov. I come from Magnitogorsk, from mechanical repair facility. I've been waiting to discuss the new law with you, TZ187, about the security of critical informational infrastructure. It's a new law, and I believe that my colleagues in the audience also have lots of questions about this law. I wanted to ask everyone, but particularly the Kaspersky Lab representative. This law is raw, not properly developed, it doesn't have clear definitions, and the situation is not exactly clear. So let's look at a shop, at a plant with arc furnaces and other furnaces. They are facilities of the metalworking industry, and the law says that metalworking facilities must be identified in a certain way. And these furnaces have their own automatic process control systems. Mechanical and electrical and other properties are controlled by a special controller connected to a computer. This is called automated workplace of furnace operator. This computer is not connected to the plant's network. So there are no external threats unless the operator himself writes a virus and brings it on a flash drive and uploads it to the control system. But our security system is telling us that this new law applies to us too. And I would like to hear your opinion as professionals. Is it really true? Where is this division? I agree that if theoretically a fraudulent person can get access to this computer, they can upload a malicious code that will cause us, for example, that will cause the furnace to open up spontaneously, and the hot metal can damage the people nearby. But still, what is the purpose of making this law, and what are the criteria of applying it, in your opinion? Maybe we didn't study it properly. What are the limits? What is covered by this law and what is not? Because The automatic process control system, in a general case, as any computer or controller or mechanism that's connected. And nowadays, this is basically any piece of machinery, because anything can be said to be covered by this law. Let me give you a brief response so that we could take a few more questions. We have a separate document on CA&I. It gives some answers. So briefly, indeed, you need to categorize the facility, and if you are included in one of these categories, then you need to go to step 2. If you believe that this facility is isolated, I'm not sure, maybe there is still an opportunity to compromise something inside your plant. And we have a number of partners who are working on assessing whether you can be included in this category. This is not our business, but there are some system integrators whom we can recommend. And step 2, if you are covered by this law, there is a series of events. The most significant is connecting to a certain GOS-SOPCA system. You incur some costs, but you will also get information about the incidents, which is important to avoid similar incidents on similar facilities. So 2 pieces of advice. If you would like to, we can talk face to face and I'll tell you whom to address. I know that many companies are now performing such investigations to realize what they have to do according to this new federal law. You had a question. You're welcome. Yes, good afternoon. My name is Vladimir Korotayev, Rostelecom. It's rather a comment to contribute to this discussion, and then I'll ask a question. As for the comment, first I'd like to support Andrei in this statement that trust is the foundation of Internet of Things. You need to build an ecosystem for this kind of complicated system, an ecosystem that includes partners and so on. Secondly, I don't agree with Alexei, and I support the previous commenter that the model of threat has changed. You remembered Stuxnet, but not Triton as the most recent example of 2017. That's an emergency protection system. Yes, it was in 2017 in the Far East, and this was a malicious software that was initially created to attack not just automatic process control systems, but actually emergency protection systems. But it's not just about the attack, it's about the response of the vendor, and this response was very positive, and the measures are taken to mitigate these threats. So of course the model of violators and threats have changed, the technologies of attacks have changed, and I'd like to conclude with a question. We've talked a lot about risks and threats, so what do we do? No one, I think, has answered this question. It would be great to hear, I suppose, Andrei's opinion at first, what to do, and then the business representatives. Thank you, Vladimir. I'll be brief. There are many people here who are in business. If we're saying that it's a risk, you can accept the risk and you can be ready and pay money in case it occurs. You can install solutions to mitigate it. You can transfer this risk, and insurance companies are now providing some options for cybersecurity cases. So accept one association if a physical asset is lost due to an attack. No one is covering this loss. Maybe it's different for large companies. So you can accept the risk, you can try to avoid it, or you can transfer the risk by buying insurance. Of course, each of the options involves certain methods and techniques, but we don't have much time. Yeah, I'm saying that we understand what we mean by cyber protection, but we don't have much time, so let's give opportunity for more questions. My name is Boris from SAP. I have the following question. What do you do in terms of supporting international standards in Russia? Not even the safe approach, but I would call it hygiene, as infrastructure is changing and Industry 4.0 is emerging and various other initiatives at the international level. So how are Russian companies supporting it, and how is this funded in Russia in terms of cybersecurity? Thank you. I suppose I can address this question to our industrial enterprises and Kaspersky Lab. I will try to give the most obvious and vivid example. There is this hype with blockchain platforms and equal access to industrial data as an innovation center. We are now trying to create IAT XML standard international IATA, International Air Carriers Association, that wants to share data between carriers, cleaning and catering companies and fuel companies, everyone involved in adjacent industries. This data can be shared. So we are now putting this XML standard on blockchain, and soon we will probably make the first blockchain payment for fuel by Rosneft and the 7 airlines. So when we are creating such a platform and opening up to everyone, there is a risk because we don't have a big experience of cybersecurity in cross-industrial solutions, and threats can emerge that were absent from our model of threats. So speaking about examples, this XML IATA standard is an example of how various companies adjacent to production companies and the fuel sector are investing in developing international standards. I'd like to say a few words to 3 examples that we are always participating in. The Industrial Internet Consortium, and by the way, we have a good test bed with SAP. Secondly, ITU, International Electric Communications Union, and APC Foundation. That's an organization that has unified standards for information sharing in the industry. And we have assigned team in all 3 organizations, and we are contributing to creating cybersecurity standards. There are public documents. If you are interested, I can give you the links. Is it viable to implement them at most Russian companies? Because usually hygiene is only about brushing your teeth, not building your platform. I'm not going to advertise some of the oil companies that were caught, but in general, the dynamics is good. I cannot say that Russia has poor protection. No, that's not true. It depends on how professional each team is and how important this issue is. If the top person realizes that such a cyber risk exists, this company has a good chance of being well protected. Kaspersky Lab has surrounded us. We are getting questions from the stage and from the audience. I think it was an attack.
As to the standards, answering your question, now Andrei has mentioned the organizations. Now we are taking part in the development of new standards related your question. And using this case, I call for all of you to take part together with us, because we are now laying the standards for the future. And there was another question from Vladimir. What shall we do? I cannot tell you what to do specifically, but I just want to say that not a single company on itself can cope with this. Cooperation is necessary, and I actively call for all those who take part and do not take part in cooperations with us and without us. Please raise these issues, try to make pilot projects and implement them into practices. Perhaps the last question we have some time to the reply. I just wanted to continue the answer towards the development, of standards, but such an organization as MEC, today we have focused on oil and gas, but I can speak about energy sector. There is a series of standards. It's all about security, internet security. So I can support Andrei Petrovich here. We have to collaborate and work and form the requirements and implement the technologies and develop them jointly. It seems that it's very difficult to finish on a more positive note. Then now, okay. Well, dear colleagues, it seems to me that, the thesis which was mentioned in the very beginning, that there is already a good base of solutions and understanding of risks has been confirmed here. I haven't been to other sessions, but it seems to me that this session was rather live from the point of view of the dialogue of the audience and the speakers. Thank you, and